This video segment is going to cover the flushing procedures for the plug-and-play family of product. Several features here about this particular product is, well, first of all, let me cover some of the important features you must have when you come to a job site to flush one of these units. You must have an adequate flush cart. What do I mean by adequate? You must have a tall cylinder that'll hold enough fluid so that allows the air to rise to the surface and dissipate rather than getting drawn back down and going into your loop. You also want to make sure you have a large enough pump. Typically in our industry, it's a 1.5 to 2 horsepower, high head, high flow pump. You must achieve a 2 feet per second velocity through your loop in order to dislodge the air. You're not going to accomplish that with a typical circulating pump. You must use a large, high head, high flow, 2 feet per second minimum velocity through your entire loop field in order to get that air out. Guys, you don't want to do this twice. Remember, you get paid for a job, do it well, do it right the first time. Nothing worse than having to come back and put all of this back together and do it again because you rushed through it. So you're going to see us exercise some patience. You're going to see the procedures. Please follow those procedures so you're doing it right and have a successful project at the end. So make sure you're using the appropriate kind of flush cart. Okay. So over here at our unit, a few things I want to point out. First of all, I strongly recommend, because with our plug and play, we have our flush ports are internal. They're behind the service panel, okay? Which means that the circuitry and whatnot are fairly exposed to an area where you're going to be connecting and disconnecting hoses. I highly recommend that you may consider holding the circuit door open, maybe even disconnecting it and setting it down out of the way so it can't get water in it. But also, I highly recommend that you disconnect the power. Okay, just shut the power off so there's no danger of should, water start to fly. Again, our internal flush ports are here. They're 1-inch female pipe threads. You're going to need to get some adapters. Typically, they go to cam lock connectors. Most of us use cam lock connectors in our industry. Guys, you want to make sure you're always locking down your cam lock. Zip ties, pins, whatever it happens to be, to make sure you're securing those cam locks so they can't come loose when you're going to pressurize the system and dislodging that air. Inside this heat pump, we have our internal Grundfos pump, okay, the internal Grundfos variable speed pump. You may have heard this already, but this particular pump is the near equivalent of 2 Grundfos UP26-96, UP26-99 pumps. Okay, it's a very nice pump. It's all internal. Guys, it has a built-in check valve, so you have to be very careful as to how you hook up your hoses. You can only go one direction, obviously. So make sure that you're bringing your fluid in on your bottom port, okay, and rejecting out this port, okay? Make sure you're doing that, okay? You're going to see some other things in here. We have an expansion tank. There's some things you need to know about that. I'll cover that as we go through the process. We also have here a bleed port so that we can bleed that air out all the way back near this expansion tank. That's important, okay? So we can find out if we've gotten all the air dislodged. You can't skip that step of not bleeding that, or you will actually have some entrapped air in there and create a lot of additional time trying to flush that air out of your system. Also on board, we have a built-in 3-way flush valve. Okay, it's a different kind of valve. Let me show you this valve here. This valve is actually installed in the unit this way. The tool of choice is a simple 1/2 inch box wrench. Ratchet wrench works very nice in here. You can see here you have the indicators for the open ports of this valve. Right now it's in the position of being in service. This area is shut off. The fluid passes straight through. We go to flush. We highly recommend that you go to the loop first. So I'm going to go ahead and orient the valve so that it's bringing the fluid in and going through the loop field first. Okay, till you're going to do both valves into that position. Both valves should always be in the same position. Okay, so you just simply orient it. When we've gotten all the air out of our loop field, then we're going to go ahead and roll it around so that we're now going to flush all the air out of our coaxial heat exchanger and through the pump. So you're going to rotate that valve so that both of them are in this direction. Now you're flushing just the coaxial heat exchanger. Final step, next to pressurization is you're going to go ahead and circulate it through the entire system. So you're going to open it up so that from your flush cart you're going both directions. And then finally, once we have achieved confidence that we have all the air out of the system, then we're going to go ahead and we're going to rotate the return three-way ball valve into the service position, which is deadheading the pump, okay, creating pressure onto the system. Then we're going to roll the other valve closed as well. We're going to take a look at our pressure gauge to make sure we don't have any tail off, and that would be a good opportunity also to bleed the expansion tank, but we're going to show you that here in just a moment. So this is the internal three-way flushing valves. Again, there's two of them. You'll see them off the right-hand corner post. Okay. One of the other components here is you must make sure that you are checking your antifreeze level. Again, one of the things that we want to encourage you to do, take a look at our previously filmed and available on the web flushing video. Goes step by step on a general or a generic type of a heat pump and loop field, but it also goes through the steps of verifying that you have the proper amount of freeze protection if in fact you're adding antifreeze. If you're in a heating dominant climate where your loop field may get down to 40 degrees entering, you must add antifreeze. You must add freeze protection. Now that we're ready to start the flushing procedure, one of the things that would be ideal in a flush cart, one of the things that I like about this particular flush cart, is the ability to use your municipal water supply and that pressure to help you flush your system, especially that loop. One of the things you must have in the flush cart, this one for example has those components, is when your municipal water comes in, you want to be able to isolate it from filling your reservoir. You want it to go through the pump. In this example, it's going to come around, it's going to go through the flush hose again into that water in port, and then it's going to go through your loop field. It's going to come back into here. It's going to come back into the top, and it's going to go into the tank. Okay, so we'll essentially fill the loop and we'll fill this tank with water just using the municipal water system. When that water level gets up to an adequate level, then we'll turn on the pump and we'll start to pump the fluid in and out of the tank, and again dislodging that air. So let me show you how this is done. Got the water pressure onto there. My valve is open at that point. It's time to rotate my valves. Again, I'm going to rotate these valves so that it's going through just the ground loop, not going through the heat pump or the circulating pump at this time. Just going to favor that ground loop. Again, a ratcheting box wrench, 1/2 inch, is a nice tool to carry in your flushing kit. I personally have a little canvas bag that hangs on the side of my flush cart so that I have various tools that I need to flush various types of flow systems. So I'm going to go ahead and turn the water on. Rotate my valve around to where I can watch it. Obviously your hoses and your flush cart are going to jump around a little bit because you're dislodging air and you're forcing it out. Again, it's under city water pressure at this point. So we're not operating the pump yet. We're going to go ahead and let the city water do a lot of the work for us and fill our reservoir at the same time. So now we have the water level up about here in our flush cart, again below our T return. We're going to go ahead and open up the valve down here and turn the pump on. Going to add a little bit more water. Adding water again to keep that water level as best we can just above that return tee. And that's pretty good on the water. Dislodging more air, you'll actually see the video, the flush cart kind of shake a little bit. That's the air coming back out of your loop. I'm going to go ahead and put a little bit more water back in. Here's some air coming back. That's good on the water. Again, we're still getting some air returning from the loop, so the pump's doing what it is designed to do, which is achieve that minimum 2 feet per second velocity, so again, we can dislodge the air. If you do not get all the air out of a pressurized closed loop system, it will simulate a leak forever. Ground loops rarely have leaks if they've been installed properly, all your welds have been properly performed. However, there's a number of loops out there I've heard of that have been condemned when in fact they didn't leak, they just were improperly purged. Remember, your gases or your air pockets will compress, liquids do not. So now that I'm not seeing any air returning back from our loop, I'm pretty confident we have all the air out. I've actually gone through a deadheading process and looking for how much compression level drop there is in our fluid. Again, please reference that on our flushing video in great detail. This is in particular just on flushing the plug and play, not specifically the loop. So again, those details are going to be on our flushing video. So now it's time to go ahead and orient our flushing valves, internal flushing valves, so that we now can flush through the coaxial heat exchanger. Now we're directing all that flow through the coaxial heat exchanger internally. Again, make sure we've dislodged all the air out of that. Please don't skip that step. It'll cause you a lot of difficulty. So we're going to keep an eye on that. We'll go through again a couple of deadheading procedures to make sure we've successfully removed all that air. Now that we're pretty certain we've got all the air removed out of the coaxial heat exchanger by again starting to do some deadheading and compression tests, now we're ready to deadhead the pump and apply some pressure. It's important while you're doing this to make sure that you have the expansion tank valve handle in the closed position, because if you leave it open, if you skip that step, what will occur is you will compress the bladder that's in that expansion tank, and it'll simulate as if you have an air pocket, which essentially you kind of do. By closing that valve, that eliminates that from occurring and makes you more confident you in fact have removed that air out. So now the very next important step is to bleed the air out of that expansion tank line. Again, we got the pump running. We're under, in this case, about 35 pounds of pressure. We're going to take a rag. We're going to depress the valve stem and get all the air out of the small pipe going out to the expansion tank. Do that until we get nothing but water out of the system. There we go. Make sure we put that cap back on. Okay. Now we're ready to rotate those internal flush valves so that we are circulating through both the coaxial heat exchanger and the loop at the same time. We'll want to let that circulate for a little while. All right, we've performed several deadheadings. We're confident we've got all the air removed. Again, this will be that point in time. If you're introducing antifreeze, you rotate those flushing valves inside the machine and introduce your antifreeze. And always, if you're adding antifreeze, you do the antifreeze level check. Make sure you have the concentration and freeze protection level that you need. We're getting ready to go ahead and pressurize the system. Again, this is a video that's covering a pressurization loop. We're going to have some others down the path here about some non-pressurized. But one of the steps you don't want to miss, guys, is we now have an expansion tank in here. You want to make sure you open up that valve. We're going to go ahead and apply our deadheading pressure with the flush cart pump. We're holding at about almost 50 pounds of pressure, so now it's time to rotate our internal flush valves. Always shut the return off first. Again, you're going to put it into the service position so that the port of the valve is now closed to the flush ports on the heat pump itself. Again, don't forget to rotate both of those into that position and take a moment to verify that it's in that position. We're going to go ahead and shut the pump off and watch our pressure gauge to see if there's any tail off. This would typically also be the time you would burp the pump. Typically a Grundfos pump, you have to burp the ceramic shaft, but these internal variable speed pumps do not require any shaft burping, so there's nothing to do back there on the pump. So at this point in time, as long as there's no tail off on your pressure gauge, which has been again mounted in here between the heat pump and the loop, you're completely purred and you're ready to go into service and do a proper startup. Guys, I can't emphasize enough. Be patient. Go through all the steps to verify you have successfully removed all the air. No one wants to come back and try and explain to the homeowner why they're back doing it again, especially if you kind of rush through this. This doesn't have anything to do with how much time you spent. It has everything to do with verifying you removed all the air from the loop and from your heat exchanger. So again, guys, do it right, do it once, do it well. This segment we're going to feature our Geo Prime Tank. Our Geo Prime Tank has a lot of features and benefits, and we're going to particularly talk about how it applies to our plug-and-play family of products. The Geo Prime Tank has a number of benefits that we particularly like here. It's a 2.5 gallon reservoir. It has baffles in it. You're going to see some graphics here in just a short little bit. It can be either pressurized up to 13 psi and make it a pressurized system, or it can be a non-pressurized system. Again, some of the features, you see a sight glass here so you can tell what your elevation of your fluid level is in the reservoir. But one of the things that we really like about this particular tank is you're going to see here that is the composite three-way valve similar to what's in our typical flow controllers. What we like about this is that you can put it in the position that you see now, and it bypasses the tank so you can properly flush a ground loop. You can hook up an appropriate flush cart and use a 2 feet per second minimum flushing flush cart to get that air dislodged. Once you've properly flushed the system, including the coax, you rotate these three-way valves so that now the fluid coming back from your loop field comes into this portion of the reservoir, and the fluid is then drawn over these baffles and taken through the heat pump. We're going to actually go through the flushing process here in our lab using our training loop. We've installed some acrylic clear plastic pipes so that we can actually see how the Geo Prime tank will do a very, very nice job of eliminating air. So again, don't try this at home, don't try this in the field. This is example only here for us in the lab. So now let's go through the process of flushing our plug-and-play family of products as it pertains to the Geo Prime tank, filling the tank, and then going through the startup operations. So we're going to come over here. As you saw previously in our flushing video, we have our hoses hooked up appropriately. What you'll end up with, by the way, is you'll have your loop coming through the top of your Geo Prime tank, exiting the Geo Prime tank, and coming into the end connection at the heat pump. One of the things you want to do with the Geo Prime tank is you want to get it in an elevation that is higher than your pump. And in this case, it's onboard pump inside our plug and play. What that does is that 2.5 gallons of fluid acts as a, well, it gives it some head pressure. It applies the appropriate amount of head pressure that the Grundfos pump manufacturers want to see on their pump. It gives you that suction pressure. So we're going to go ahead and we're going to start the flush cart in a moment here, and I'm going to rotate my flush valve so that I'm favoring just the loop. Again, bypassing that coax. Okay, we're ready to flush the system now. So now that we've completed flushing our lab loop here and the coax through the heat pump, as you saw in a previous video, we've already opened up the valve that goes to our expansion tank and bled the little bleed port here between the coax and the expansion tank. Now it's time to actually add the fluid into the Geo Prime tank. You have many of options, of course, garden hose, things of that nature, but shoot, if you've got a solution of brine material in your flush cart, you might as well use that as the additive into your tank. So we're going to go ahead and add the fluid into here, keeping an eye on our sight glass, see how we're doing. So now that we've finished filling our Geo Prime tank, which again holds about 2.5 gallons of fluid if you filled it all the way to the top, you can see our fluid level is about here in the sight glass. So there's a couple inches on the very top of the tank that still has air in it. Going to go ahead and replace our cap, make sure it's on good and tight. And now we're ready to put our tank into service. So we've actually had our valves in a position where the off portion of the valve was pointing toward the tank. So we're not flowing through the tank. We're bypassing the tank for, again, flushing purposes to make sure we get the air out of our system with the proper flush cart. Now we're going to rotate these valves so the off position is here and here, so that the flow is going through the reservoir and back down through the valve into the heat pump itself. And now we're ready to show what the system looks like when it's in operation and how well it'll do to remove a good amount of the air that might still be left in your system. If you didn't do a thorough job of pressurization and flushing, then this can actually take care of a bit of air. Don't rely on it and exclude a flush cart. That will never be successful. All right, so we've just activated the pump on board our plug-and-play family of products, so we're now circulating fluid, and we've rotated our valves so that now the fluid is coming into the tank, going through the dip tube that comes down in this vicinity. Fluid is going to be routed and down through here. Just as a graphic display of how well this will do to help eliminate any air that perhaps you weren't able to fully get out because you might not have had quite the adequate flush cart, I'm going to inject a little bit of air with this tire pump. And you'll see the air coming into the tank, and it's going to capture most of it. So you can see that air coming into the tank being carried by the pump, but as it exits to go back into the heat pump, it's pretty darn clear and pretty void of air. Let's try this again. So you can see, again, the acrylic clear piping is for our use only, just to graphically display how well the Geo Prime tank will help to eliminate some of the air and hopefully cause less cavitation on the pumps, again providing that head pressure, and make it so it's a much less maintenance required system. We think it's a good addition to our quality products, and we hope you'll consider trying a couple of them out.